Ready? Okay, today we continue with Smart POS again. All right, all in. 15, two more. Okay, let's see. All in, huh? 16, one more. Who is not here? Let's see who is not here. Angeline, everybody here. Okay, except Xing Yun not here, is it? I think Xing Yun not in. Okay, let's start. Okay, I just realized, okay, this next week is week 12, okay? So instead of your assignment, you can handing in week 13, week 19. Okay, you do your presentation, okay. All right, you can handing, all right, on 19 extra for me to read through. Then you do your presentation on Thursday or week 13. And okay, we will go through Smart PLS, the software next week. And then, okay, then you will probably do your assignment in week 14, and then you have study week 15. That is the week also for your assignment. Okay, so we have 2 more weeks to go. All right. Okay, so now we start with this. Okay, we have already gone through the outer model. All right, so now we look at the inner model. Okay. So inner model, we call it structural model, right? So there is this assessment of structural model called for collineary issue. Collineary issue meaning that the items in the variable, whether they are overlapping, are they the same or not. And then assessment of the path coefficient, that is your IV and your DV, whether there's any relationship. And then assessment level of R2 also. The assessment of the effect size. Okay, assessment of predicted relevant Q2 or Q2 effect size, assessment of GOF. All right, so we'll go through one by one. That is for the independence relationship with the dependence variable. We call it structural model assessment. Okay, so assessment of this collinearity. All right, collinearity is a conditions. Okay, some of the independence variable are highly correlated. As I mentioned just now, whether the items are in your variables are they correlated, and then all your independence, each of these independence are one by one. All right, your factors are they correlated or not? So collinearity tends to inflate the variance of at least one estimate regression coefficient. Okay, so whether the independence variable they are highly correlated, meaning highly related. Okay, variance inflate factor is the estimation. All right, so this one variance inflated factor VIF is used to measure if two variables are having collinearity issue. Okay, so in the structural model, all right, collinearity among Langdon's variables are assessed to this variance inflated factor VIF. So these variables, the threshold for this structural model VIF is similar to measurement model VIF. All right, so greater than 5 indicate a potential collinearity problems. Okay, so this is the one that you must take note. All right, so these VIF factors, when you generate, it cannot be more than 5. If it is more than 5, it indicates a potential collinearity problem. Okay, all right, so you look here is an example. All right, slightly bigger, easier to read. So you see here, this one VIF they have here. Right, you see all this mobile usefulness. Okay, so it's achieved both the standard. Okay, show the indicate multi-collinearity as the variance of the does not exceed 5. Okay, this one does not exceed 5. Okay, okay, more than 5. So this one, so all this is less than 5. So there is no multi-linear collinearity issue. Okay, all right. Do not exceed. These are all the different factors. They run out this variance inflated factor value. All right, is less than 5. There's no collinearity issue. This is how you report. Okay, okay, bootstrapping. Okay, all right, bootstrapping meaning that, for example, you only have 10 sample size, but you bootstrap to become 1,000. Okay, there's this function to increase as though it is 1,000. Okay, so part coefficient for relationship among Langdon's variable are obtained through bootstrapping techniques. So you use this bootstrapping. So inferential statistics, all right, are obtained through the use of bootstrap standard errors. We can use this t-test. Use this bootstrapping. T-value of significance is 1.65 for one tail, okay, and 1.96 for two tail. Okay, again, this is the indicator that you must know. Okay, all right, so t-value, one tail is 1.65, two tail is 1.96. Okay, so latest development is, okay, we still have one not in. Latest development of statistical analysis, all right, required reporting of confidence interval. Okay, no zero straddle in between the bias corrected confidence interval. Okay, require the reporting of confidence interval. So you must report your confidence interval. Make sure there's no zero in between. So this one, you have the mean t-test here, right? And then the p-value. Okay, all right. So using this bootstrapping, the 5,000 was analyzed, show that 10 out of 11 hypotheses were supported. Okay, it's not support with p-value more than 0.5. Okay, so this one more than 0.5, so not supported. Okay, this is reaffirmed by this bias correct interval which contains zeros. So you see, this one there is minus sign here. Okay, so this one confidence interval cannot contain zero value. Is that clear? For the hypothesis to be supported. All right. So this shows the different significant level. All right, 0.5. This one more than 0.05. So it's not supported. This is how you report. Any questions there? All right. So this is the t value. Okay, this one two tail. Okay, less than 0.5. If it's 0.1, its t is 2.58. This one 3.3. All right. T value or p value. Okay. So here is another example. Variance inflation factors. Okay, range from 1 to 3.83. Okay. All right, so this figure 2 shows were supported. This one those were not supported. All right. Okay. You see here. Okay. So 0.98 less than p-value, right? Less than this one p-value less than 0.01. Okay. All right. MSE, this one MSE. Okay. 0.19. All right. P less than 0. How is it? This one P19. Okay, you see here. 9 shows that 9 out of 11 hypotheses were supported. All right. H3 is here. Okay. H3. Okay. And H9 here. All right. All others hypotheses were supported. So you look at this hypothesis, you look at the figures here. Okay. All right. So you see here, right? Okay. Okay, you see MEOU, right? MEOU here. All right. So path coefficient is 0.26. All right. And then value is less than 0.01. Okay. All right. MU is here. So you see MU here, path coefficient 0.98. All right. This one is less than 0.01. Okay. So MSE, here MSE, okay? 0.19, this one is less than 0.01, okay? 0.01, so it's 0.008, all right? Okay? All right? Any questions so far? All right, so you should know this one. BIF greater than 5, okay? All right, so these are examples of models that we use from Smart PLS. Okay, so here is another reporting on Smart PLS. So with p-value of 0.05. Okay, so you look at table 6 here. Can you look at this? Okay, see whether you can follow any questions. Can you please ask? All right, so this one, the relationship, make sure this one is, okay, p-value of 0.05. Okay, here all less than 0.05 except H2 and H6, yeah. Okay, except H2 and H6. Okay, and any question with this? Hello? Any issue with this? Okay. All right, huh? Any question with this? So meaning that in your final assessment, all right, if you are required to do this PAP coefficient, all right, and then this p-value given, you must put down whether it's support or unsupported. You must follow this way of interpretation. Is that clear? All right, so these are examples of this, the PAP coefficients. You put it here. Okay. Okay. All right, so this one, you put it here, all this, okay? The relationships, the PAP coefficients. All right. Okay, so another example here. Inner structural models, all right, was performed using 500 again with bootstrap. This one, later as you use the Smart PLS, this one 5,000 is the max. It can be the maximum, but you can use 1,000, 3,000. It's just that 5,000, it takes a longer time to bootstrap, okay? At 95% confidence interval, so p-value of this patch coefficient, all right, is at 1.6, 2.5, shows a significant level of 0.1, this one, all right? Okay. So this one, recently the scholar, they did bias correct confidence interval measure, there's no zero in between. Is that clear? So the results indicate, this is the different ways of showing you how to interpret. Is that clear? Has a significant relationships, positive influence, the impact of this. All right. Okay. So the model is capable of explaining 21.2% of the variance in BI according to this. Okay, the value above 20% is considered high for consumer behavior studies. Okay, so these are the way we interpret and then you generate your results. Okay. Okay. Any questions or not? Your final assessment, there's this interpretation, so you must know, all right, so this is another one. Sorry, is a bit small. I found it difficult to see, to read myself also. Okay. All right, so this one, outcome of a structural model examination that you have here. All right, sample means the p-value, the bias corrected confidence interval. So here you see, this one minus sign, that means got 0, all right? That means not supported. Minus sign got 0, minus sign got 0, got minus sign got 0, all right? This one also minus sign, so there's 0. This one minus sign, okay? This one all minus, okay, this one got 0, all right? Any problem with this? This one, you see, this the reporting on this one. This part is explaining this part here, okay? The figures are here. All right, so for example, we just look at one, okay? PEEESI, okay? So, EE, okay, what is this? Figure 2, okay? This one is this. This is figure 2 here, okay? All right. So BI is behavioral intention, EE is effort expectancy. So here, all right, the results indicated PE, EE, and SI, okay? Hypothesis 1, okay? So you look at this hypothesis 1. Where is the hypothesis 1? Oh, here, okay? PE, BI, okay? Here. All right, 0.13. All right, so yes, supported, 0.15, 0.18, no zeros, and this one is less than 0.05, okay? So you see here, all right, less than 0.05, okay, has a significant positive relationship with BI, behavioral intention, as was hypothesized, okay? So that's how you interpret the thing, okay? Any questions? These are examples, these are examples for you to see. Okay, and then next Tuesday we will listen to the video on this Smart POS, then you will run on it, okay? If you can, you download your Smart POS software, then Tuesday, right, you can follow the video, okay? All right. Okay, now we look at assessment of this R square. So according to this Ching, this person, R square value for endogenous random variable are assessed as follow, all right? So 0.3 is moderate, 0.19 is weak, so 0.67. So we need 0.67, Park coefficient range between 0.3 along with measures that explain 50% or more variance is acceptable, okay? All right. So according to Cohen, right, R square value for endogenous random variable are assessed as follow, okay? So this person, 2.26, 0.2 is substantial, okay? So they also mention, according to this low molar, Park coefficient greater than 0.1 is acceptable, So it really depends on your findings, when you generate, if your range is like this, right, you must quote this particular person, okay? The R square value should be high enough for model to achieve a minimum level of explanatory power, okay? All right, facts. Fox and Miller recommend that R square value should be equal to or greater than 0.1. So this one is according to this person, Fox and Miller, 1992, okay? It should be greater than this in order to explain the variance of a particular endogenous construct to be deemed adequate, okay? So here is another example, all right? So here you have the construct, intention to adopt mobile usefulness is of use, okay? So R square here is here, all right? So the study circulate this one, It was recommended as based on this, the path for intention to adopt MU large predicted relevant because the Q2 value are above 0 and more than 0.32. This one is Q2, okay? But you look at R2, R2 value is 0.662, okay? As such, predicted accuracy of the model is considered to be moderate as it is above 0.5 but below 0.75. Okay, so this one moderate, okay, above 0.5. Okay, let's see. All right, this one. Okay, equal. All right, this one 0.5. Okay, you see, because it's less than 0.67 substantial, so it's okay. That's how they interpret, 0.667. Okay, okay, so it's above 0.5. Okay, but below 0.75, you use 7.5. So we have to check this one is which citation. Okay. So if it is according to Qing, this substantial is 0.67. Okay. All right. So assessment of R2 here. Another interpretation. Okay. All right. The model is capable of explaining 21.2% of the variance in BI. Okay. According to this person, the value of above 20% is considered high for consumer behavior studies. All right, but R2, okay, so far you just know it lah, okay, because the pairing lecturers, he did not ask about this R2 so but I just let you see this, okay. So this one F2 is the effect size. So Cohen 1988 proposed the following: higher than 0.2 is considered small effect. Higher than 0.15 is medium. Higher than 0.95 is large. So assessment of effect is science. This one allowed the researcher to observe the effects of each exogenous construct, okay, on endogenous construct, which IV explain and predict PV better, okay. All right, so this is the effect size, okay. So 0.02 small, okay, 0.15 medium, 0.35 large, okay. So significant part coefficients with very minimal effect size do not justify scholarly or managerial attention, okay. All right. Okay, so that's the effect size. All right, so here another examples on the this. So in relation, is it too small for you all or not? Can you all read the text small? Is that better, Is this better? Can read? Hello, everybody. Can read or not? Can Okay, so this is another example here. All right. So the effect size for each exogenous is calculated in this table. The effect size F2, all right, how much an exogenous random construct, all right, contribute to an endogenous R square value, okay? So according to this, all right, Geffen and Stroud, if the effect size indicate weak, medium, and large effects, if the value range between 0, okay, to this and above 0.35. So in the event, if the value fall below 0.2, the endogenous construct has no effects, okay? So as shown in table 11, they have a weak effects on BI, okay? MPC and PEJ, all right? Below 0.02, okay? So let's see here, MPC BI, 0.023, okay? This one is above, okay? 0.023 and 0.14, okay? All right? And then PCM also with effect on CI. PCM. PCM is here, okay? This one. SI, this one. PISI here, okay? PCSI here, all right? This one. PCM 11. They have a weak effects, okay? So in the value fall below 0.02, okay? Has no effects, as shown in this. They have a weak effects on BI with value of 0.23, okay? This one 23, 0.023, and then 0.018, okay? 0.02, okay? Yes, all these are below, 0.02, okay, 0.02. All right, this one is above, 0. This one, this two, is above 0.02. All right. Any question with this? Okay, so this one, higher than 0.2, small, okay? Higher than 0.15, medium, okay? Higher than 0.35, large, okay? The effect size. All right, exogenous on the endogenous construct, okay? All right. So blindfolding predictive relevance, okay? This one, just know, all right? We don't do blindfolding. So interactive procedures, all right, in which different parts of the data mix are omitted, okay? The logic of the data point omissions, number of observation remain the same as the original set, So this one blindfolding predictive relevance, is just a functions available in PLS that we can do this blindfolding, okay? So estimate based on reduced data sets that are used to predict the omitted data point. So data omission, model estimation and prediction use several rounds so that in the end, every data point has been omitted and predicted, okay? So involving determine the omission distance, okay, with a value between 5 to 12, okay? So Q2 value larger than 0 indicate that the exogenous construct have predictive relevance for the endogenous construct. So this is what you need to know if you do this blind folding. This one, the Q2 value must be larger than 0. The exogenous construct, they have a predictive relevance for this endogenous construct. This is a relationship, okay, that is can predict Q2. All right, so the number of cases, okay, in a data must not be a multiple integers number of the omission distance. So interpret the cross validation redundancy. Okay, so this is the value you need to know. Just now we learned this one must be larger than 0. So larger than 0. Okay, so it's between this week. Okay, more than 0.35, there's a strong predictive power. Okay, all right, so that's the formulas for that. And then here, all right, the studies examples here. So you have this Q2, this one all greater than 0. Okay, all right, so here you see the Q2 here. All right, so greater than 0 indicates the model exhibits predictive relevance. Okay, so the model is okay, you can use it because this one is more than 0. Okay, all right, if it is less than 0, late of predictive relevant. Okay, and then the next one, goodness of fits. So upon the confirmation that the construct measurements are valid and reliable, right? Standardized root mean square residual, okay, this one was adopted to assess both estimates and structural model. For the global goodness of model fits, this result show that the structured and estimate model is 0.33, 0.05 respectively, which is less than 0.8 to show the model fits was good. Okay. All right, so based on this, Hu and Benkler, they use this benchmark of 0.8. All right, the fitness of the overall model. Okay, so these are examples of this goodness of fit. Okay, you use this confidence interval, less than 0.8, to show model fits was good. Okay. So any question, these are things that you need to generate your results, and then examples here, it teaches us how to interpret the thing, okay? The results, okay? Of this smart PLS. So you can actually look for this journal, this one, Gentle and Edge. Do they really moderate mobile tourism? Okay, we will take 2 minutes break, then we will come back, okay? Okay. So again, for your assessment, okay, it will be something like this. Ask you to interpret Crobash of all these things and convergence. So this is the summary that I have. So these are the things that you must know, what I covered for you for this. All right. For this smart PLS, the external model and internal model is the understanding of this smart PLS. Okay, that you need to know. All right. So any more questions on this smart PLS? So next Tuesday we will go through the video. All right, with all of you, and then you must follow the steps as you need to know exactly what to do, and these are things that you have to do in your final assessment. Okay, I don't know what the final assessment will be like, but previous assessment, okay, this is something that you need to do. Okay, any more questions? Any more question on this? And then your assignments, do you have any questions? Do you have any questions? Any questions on all this? Or else if you have no questions, all right, we can proceed with the video. Okay? Hello? No response, And any response? Hello? Assignments, any question? Assignments, any questions? And then this interpretation of smart PLS, any question? Okay, no, everybody, no questions. I think I will just continue with the video. All right? Then you can pick up, okay? So before I start with the video, I just have to do no, you can follow, which is good. Okay. Okay, so the coming Saturday. All right, have anybody already keyed in the figures in an Excel file already or not? Hello? Have you all keyed in the figure that are uploaded to Google Form? No, not Google Form, Google Classroom. Have you put it in the Excel file? Not yet, Can somebody do it? Then you just share among us, okay? Hello, any volunteer to do that? No? Anybody wants to do that? Or one person do exercise 1, one person do exercise 2, put it in the Excel sheet. Can somebody do it or not? And then you can share among yourself. Hello? 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 Nobody, Nobody wants to eat. If you don't do that, how can you follow the class on SPSS on Saturday? The workshop. Who wants to do it? Hello? Not much, right? Any volunteer? Any volunteer? No, Hello, do you know what I'm referring to or not? Hello? Hong Yu? Presentation and test on Saturday. Why is it that they put it on Saturday, How about the others, the rest? You all have tests and on Saturday? So many having tests on Saturday. This is funny, huh? This is really funny, okay? So actually you all miss it, huh? Mm-hmm. Okay, so who is able to go? How come? Hello? So how many of you are not able to join? 1, 2, 3, 4, 5? 5 of you? Hmm? 1, 2, 3, 1, 2, 3, 4, 5, 6. All right, because the workshop is actually hands-on on SPSS is really good for all of you to join because your final year project you may use Smart PLS or you may use SPSS. All right. So if you have class or test, all right, once you finish your class or your test, you quickly join. All right. So you still have to get ready. That's why I said instead of everybody prepare the Excel sheet, all right? Can just one or two you volunteer, one do exercise 1, and then one do exercise 2. Then you just share the Excel worksheet on the group WhatsApp group so that everybody can use. Okay? Clear with what I'm telling all of you? Hello? So whoever, right? If you have the time, you do the Excel sheet. Actually, it's very simple. You just copy and paste it into Excel sheet. All right. Then you just share to everybody. Then you need that, all right, for your Saturday workshop. Okay. Do I make myself clear? All right. Okay. So before I go through the videos, all right, on Smart PLS, these are the things that you know. This is the Smart PLS software. Okay. As I mentioned, all right, you must download, okay, in order to follow. All right, these are the things that you download the professional version. They give you trial 1 month, okay, then you activate. All right. Mm. So now, Let's see, where is it? Mm-hmm. Okay, I just hold on. I cannot find the video. Where is it now? Supposed to be here.
This slide first before we can proceed on to the structural model. Structural model basically means that test pattern. Our latent constructs are actually significant or not significant. Oh, I'm so sorry, I forgot to record recording. Sometimes recording. Let's internal consistency. Destroy as so I really covered this last week. It cannot be anything less than that. So today I'm going to move on to the next one, which is that otherwise what we call discriminant variability. Now, what is that variability? So I have also already shared my
Okay, sorry, I need to find the video. That is not the one. All right. Okay, so for waiting, can you discuss among yourself on your assignment? All your assignment almost all done already or not? Hello? I only have 3 groups sending to me. Where's the other group? Shelly Gong, your group? Is it done? Hello? Shelly Gong, are you there? Who is with Shelly Gong? Hello? 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 Is Shirley gone there? Xing Ying is not here today. The group, have you done? Ian, are you with the group? No response, how come? Hello. All right, which group has not? Su Yan, your group has you give it to me or not? Hello? Group 4, have you sent your draft to me? I know there's one group who give it to me, but I haven't read through. Are the group there? Okay, just tell me group 1, have you sent me your draft? Group 1, yes. Can you just speak out? Group 1, have you sent me the draft? Yes or no?
Yes.
Group 1, yes, I haven't returned, is it? I have not returned, is it?
Yeah.
Last one, I returned already, right? Angela Su, your group?
Yes, but I also send new one to your email.
Okay, new one. Jialin done. Jialin group done. Xing in your group. Ian, your group. Shirley gone? You sent in already or not? Hello? This is the group that has not sent in, yes or no? Hello?
Yes.
Have not sent in, right?
Oh,
Is
I
it?
think so.
Have I gone through? Have you sent it in? Yes or no? Yes, send me, but I haven't read, is it? Have you sent it to me? Just answer yes or no. Hello? Not yet, huh?
Oh,
Like,
yes. Okay.
not yet, yes or no?
Oh, yeah.
Not yet send to me, right? Okay, then I know, huh? So you better send it to me, huh? Not yet send in, huh? Okay.
Okay.
Okay lah, now at least I know, huh? Okay. So, okay, but anyway, because I cannot find the video now, I don't know where is my file. so, so any other questions? I think I will stop here, then I will find the video, then we will go through Tuesday, all right? Then you do your presentation, all right? So presentations, the templates I have already given out, so you try to do that, okay? So any other questions on your assignment and then on your final assessment? Because I want you all to do well, and then we need to monitor your performance. So if you are doing very well in your midterm, make sure your final assessment, you also have to do well. Is that clear? All right. So any question you want to ask me? or else I think I will finish for today. So remember the SPSS workshop, if you can, please attend, okay? All right. So assignment, all this no questions. If it's no question, I think I will finish for today. So Tuesday, I will go through the video on SPS on Smart PLS. This is what you have to do for your final exam. Okay, final assignment. Okay. All right. So if no question, we'll finish for today. Okay. Okay. Bye bye.